All right, taking a look at arc length. Now with arc length, remember this is not the same as a central angle. That's arc measure, but we're going to use the central angle. So x in this equation represents the measure of the central angle or the measure of the arc, however you want to think of it. But anyways, the length of the arc equals x over 360 times 2 pi r. Now 2 pi r, we haven't gotten into it a ton this year, but that is the equation for the circumference of a circle. So if we wanted to know the length of the entire arc around the circle, the whole circle there, that circumference would just be equal to 2 pi r. So when we're using x over 360, this is basically a fraction saying, okay, we want to know the length of this circle, but only this part of it, this portion. Because 360, if you're thinking of it, can represent the whole circle because it's 360 degrees around. Think about a semicircle, for example. That would be 180 going in for x there. 180 divided by 360. If you simplify that fraction, you're going to get 1/2. So it represents half of the circle. Now, in these examples at the bottom here, we'll be given a number to throw in for x, so it won't just be a semicircle. All right, so let's take a look. All right, so on our first example, looks like we got a central angle of 75, so we can throw that in for x in the equation. So I got 75 over 360 times 2 times pi times the radius, which they gave us is 4. Now, my strategy on these is I basically multiply everything that's going to end up in the numerator. So I did 75 times 2 times 4. That's where 600 came from. So the length of this arc is going to be 600 over 360 pi. Now, if I wanted to leave this in terms of pi, I would simplify this fraction. They're looking for the number rounded to the nearest tenth. So I just took my calculator. I did 600 divided by 360. And then multiplied that answer by pi. You could type in 600 pi divided by 360, however you want to do it. But you should get 5.236, and when we round out to the nearest tenth, this arc has a length of 5.2 inches. All right, looking at the length of YZ again on this one. They gave us the central angle again, 130 this time. Now, the only difference is that they gave us a diameter instead of a radius here. So if we want the radius, you just have to divide that diameter by 2, and we'll end up getting 5 for that. Now, another adjustment you guys could have done, instead of doing 2 pi r at the end here, you could have just done, pi times d. Because think about it, 2 times the radius is the diameter, so we're just going to get back to that number 10 anyways. So that's one shortcut you could do in the future, is just do pi times the diameter at the end here. Or if you really want to stick with the original equation you were given, you can, turn it into a radius and then multiply it back to a diameter, essentially. Anyways, plugging into the problem, we get a central angle 130 over that 360 times 2 pi 5. So we end up getting, when I multiply the 130, the 2, and the 5 together, that is 1,300 for our numerator. So we have the length is 1,300 divided by 360 times pi. Now when you crunch that on your calculator, 1,300 pi divided by 360, you're going to end up getting 11.3446. Rounding it to the nearest tenth, we have an arc length of 11.3 centimeters.